Hello, welcome. Uh, it's time for our next talk, and that's going to be building agentic LLM workflows with Autogen. Our speaker is Daron. He is a tech lead at Microsoft, specializing in Azure AI applications across 109 countries in Central and Eastern Europe, the Middle East, and Africa. With over 20 years in tech industry, his expertise includes solution architecture, software as a service development, and cloud native architecture. Before joining Microsoft, Daron founded a company, served as chief technology officer for two startups, focusing on building software as a service products. He's also an author, having published a book on NoSQL databases. Welcome to the stage, Daron, and we now turn it over to you.
Hello, everyone. Welcome to the session. Hopefully, you're enjoying the entire conference. So, in this particular session, what we're going to do is to take a peek into Autogen from some simple stuff to the complex in that order. So, okay. So, if you want to stay in touch, obviously, this is you do see on your screen right now my social profile and all that, and the QR code goes to LinkedIn as well, where you can find a lot of updates that I share about AI as much as I can do. Okay, perfect. So let's jump into this. So the first question, right? Why agentic systems matter at all, right? Why do we care at all? Couldn't we just go and, just put a prompt and be done with it? Maybe at one point it's going to be. Maybe at one point we're going to be able to do that. But today, when you look at the LLMs, not only to improve the performance of the LLM, because, when you got two LLMs together talking with each other, go figure, they do a better job. And then obviously there are additional tips and tricks that we can do. And we're going to see a couple of these examples today in my demos as well, where we can personify different LLMs with different characteristics and have them contribute from different perspectives and work together and orchestrate those different agents together to be able to keep up working to come up with a higher quality result based on what you want. So today, the agentic systems, the reason we care about it is simply to get to a higher quality end result. Obviously, it's not cheap because we're having machines work for us a little bit more and multiple machines, not necessarily physical machines, but I'm referring to agents as machines because at the end of the day, every agent is consuming some, electricity, water, and all that, some compute power. But the results are, as long as the results are higher quality, we'd love to do that. But obviously, not every agent comes into the picture just because of an additional, LLM with a different perspective. Sometimes we combine different models, right? And we will talk about that as well. So long story short, the agentic systems matter just to get to higher quality results, putting more power into the system. And when we look at Autogen, there are actually a little bit of a confusion in there. There would be if you start doing some research about Autogen, which is there are two different Autogens. One of them is a fork. So today, most of the demos that I'm going to do will be AG2 actually. So Autogen on 0.2 versions, it forked out. Everything that we're talking today is open source, by the way. Both of the Autogens are open source. So it started at Microsoft. There is a fork outside there. It's called AG2 that forked out from version 0.2. And then Microsoft keeps building the Autogen into 0.4. I would accept that this is, adding a little bit of a complexity and confusion probably, but this is the nature of the beast when it comes to, openness, right? So we can fork out and start building your own thing. And a lot of the demos that I'm going to do today are going to be on the AG2. You can switch or even combine these two different forks together in your projects based on your needs. So Let me look at the slide to make sure I didn't miss anything. Yes, we kind of covered why Agentic Systems Matters, Autogen, an open source multi-agent framework that can operate agents autonomously and collaborate with humans, which is the part that I missed, which is very important. When these agents work together, we want to be in the picture as well, sometimes, because human oversight is helpful. So we want to be able to work with these agents in the same room together, and someone has to help us to orchestrate the communication between those agents and ourselves as the human. Otherwise, we're going to need to do a lot of plumbing, which we don't want to. And that's kind of the purpose of having a framework like Autogen to come in and help us orchestrate all of this within a single framework. That's going to be helpful. So what are the foundations? So there are three primary foundations that we have to put aside to understand the agents and the Autogen architecture. The first one is that every agent has to be autonomous. So agents can make decisions and iterate on tasks on their own. An AI agent decides how to break down a problem, for example. That's the autonomous fashion of an agent. Can make decisions on itself independent of the other agents based on the circumstances. So autonomy is important, per agent autonomy, right? And then obviously collaboration is important. The framework should allow that. Agents can communicate and work together or with humans to solve particular problems that we throw at them. And they can share information with each other. They can share results with each other. They work on something, one agent can work on something and then bring in the result and share the result with another agent, and they keep collaborating. And adaptability is the third one I want to touch on this slide. Agents can be specialized or equipped with tools and skills and adapt to different tasks or domains. So when we're designing agents, we don't only bring in an LLM that's going to back up the intelligence part of the agent, but we do bring in skills and tools into the picture as well. So for example, an agent can have the skill of using your internal company ERP system, right? Or an agent can have a tool that will allow the agent to execute code, write code, execute, take the result within a sandbox. So that would be a tool for the agent. Or, like I mentioned, a skill that you expose. And those skills, usually they have to be developed. But what the framework does is keep the relationship between the tools, skills, and the agents and the backing LLM chosen for that particular agent, keep the relationship between all of these things and making sure an agent is represented with all the skills and tools and the intelligence backing up that agent into the collaborative environment in an autonomous fashion. So those are the three big pillars we have to have. Okay. So going into the architecture a little bit more, so there are a couple of things we should discuss here as well. The architecture of Autogen, it provides a unified conversation framework for multi-agent interactions. So that's how collaboration goes through. Agents in Autogen are conversable, right? They send and receive messages to other agents, and customizable, which means they integrate with various LLMs tools, or they represent human input. So some of the key components that you can think are, assistant agents that has the AI role using an LLM, that's a problem solver, or user proxy agents simply simulating a user with humans, or sometimes we use the user proxy agents to simulate and represent a tool as well. So these two, assistant agents and user proxy agents, they are the building blocks to pretty much everything that we build with Autogen. And Autogen itself handles the orchestration of messages between those agents, so developers can simply focus on defining agent roles and goals instead of low-level communication between agents and how it's going to work. With that said, sometimes you might need some customization, and that's doable as well. One example would be, you might want to control the communication between agents, and you might not want one agent talk to the other, or you might want to keep the communication between those agents sequential in some situations, and the framework has that flexibility too. Okay, so what are categories of design patterns? We do have design patterns. Design patterns are always in there, right? So we kind of came up with design patterns for agentic systems as well. There are 4 primary ones that I want to discuss before we jump into the demos. So the first one is reflection, and you know what? Okay, I'm going to go really fast quickly here because I do have some diagrams that I want to share with you. But the reflection is an LLM examines its own work to come up with ways to improve it. That's as simple as the reflection. And then there's tool use, where an LLM is given tools such as web search, code execution, or any other function that you can imagine, helping the agent to gather information, to be able to take action, maybe file system access or process data. And then there's the planning pattern, where the LLM comes up and executes a multi-step plan to achieve a goal. For example, writing an outline for an essay, then doing online research, then writing a draft, and so on, so forth. And that the planning can be separate from the execution if there are multiple agents taking different responsibilities. And that leads into multi-agent collaboration, where more than one AI agent work together, splitting up tasks and discussing and debating ideas to come up with better solutions than a single agent can do. Okay, so I do have some beautiful charts here that I can share with you. And at the end of the session, I'm going to share a link where you can download the presentation as well, and even the sample codes that I'm going to use. So this is the self-refining reflective agent. So this is about doing an iterative refinement with self-feedback. There's a prompt that comes in, we generate something, we have an output text, then we take the output text and we ask the agent to reflect on it. This reflection could lead to an improvement in the quality in terms of fixing mistakes, or simply following instructions in a higher quality way than it was on the first round. So this is as simple as that. You can have multiple agents, but the reflection pattern isn't necessarily designed to have multiple agents, but you can if you want to. So it wouldn't be called reflection anymore, but my point is, so this reflection could actually be done by someone else, and the feedback could be taken and transferred into the initial agent. But again, reflection is usually about the single agent iterating through the same task to make sure the task has improved. I'm sure you might have seen these when you're using ChatGPT or something. You come in, you write something, and then you say, hey, double check your answers. And it comes back with a response that says, hey, I'm sorry, it looks like I did a mistake. So that's the reflection part that we see pretty much every day. So then the tool use. So user gives a prompt. Then there's a tool selection that has to happen, right? So the tool selection happens through the LLM as well, and the framework manages how that is supposed to be done. Once the tool selection is done, like, hey, it looks like this is what the user wants to do. Here's a tool that I have. Here's a tool that I can use out of the tool inventory. Then the tool execution has to be orchestrated as well, depending to the tool's needs. And then the output has to be piped back into the generated content for the resulting text. And all of the plumbing and management in this case will be done by the framework itself. So another one was planning. So this is a little bit more complicated. I'm not going to go into all of the details here. So here, what we have is there's a single task. It goes into a planning phase. The planning phase spits out multiple tasks. So it generates tasks, and we iterate through that. We take every task. For every task, we might have a different agent. One thing that is a little bit different here is the react and review. Again, I'm not going to go very deep into this because that's not our topic, but react enables the LLM to dynamically alternate between reasoning, thinking through the problems and acting, performing the specific task. So, and this allows for more adaptive and flexible planning. Review, on the other hand, enhances the planning pattern by using an open world ontology to guide reasoning. So when you download the stack, you're going to see references to research articles. If you're interested in learning more about these, implementations, there are research articles on additional information, additional references, resources that I have in the slide deck that you can go and take a look at. And finally, there is the multi-agent collaboration. This is the visual I wanted to use for that, because at this point, it's pretty much endless. You can do whatever you want. You can bring as many agents as you want with different skills, backed up with different LLMs based on their intelligence needs. It can be a small model, a large model, or whatever. It can be a specific model. At that point, it's all about managing your agent inventory with the skills, tools, and the LLM backing up each and individual agent. And then you decide, hey, this is this agent inventory that I have. So now I have a problem at hand, and these are the agents that I'm going to use to tackle this problem together. So that's kind of pretty much what the concept is. Okay. And that brings us to our first demo. Okay, let me see. Here we go. Cool, cool, cool. So this is the first demo that I wanted to run. But before we run, I just want to, let's make this a little bit bigger. Okay. So I just want to go through the code a little bit so that we understand. Then we're going to see the execution. So here, what I have is, first, I have an assistant agent. So I obviously have to give it a name. Then I'm given the configuration for the LLM that I'm going to use. At this point, it's an LLM running on a regular Intel CPU. And then I got a system message for this particular agent using the LLM behind the scenes. So, and it says, respond in plain text only. Make sure you mark the end of your response with and. Okay, that's important, because when these agents are talking to each other, which in this case, this is a single agent, but sometimes these agents are very chatty, right? I mean, they keep talking. So we have to understand what they are when they are done with what they do. There are different ways to do this. You can say like, hey, I'm going to limit the amount of tokens that you generate. Or you can say like, hey, you can only talk 4 times, 4 round trips, and that's it. Or you can simply say, hey, instruct the LLM itself to let me know when it is done. So obviously, out of all of these options, this one is the kind of the highest risk. It depends what model is backing up this agent. If the model is good in following instructions, because at the end of the day, you are giving an instruction for the LLM to say and after they are done. So if they don't say that, then you have to still have kind of a hard limit. So I would still suggest having some kind of a hard limit while you're experimenting, even in production. And then we have the user proxy that represents the user. So we give it a name. We say human input mode never. In this case, this is going to be fully autonomous. There isn't going to be any human intervention. Code execution config false. So the user proxy agent sometimes will simply have code execution skill given for this proxy. If we do that, whatever code that is being written by an agent can be executed by this proxy. So the proxy represents the skill within the room. And this is not a multi-agent system, so we're not going to go there. And for code execution, Autogen supports different environments. You can have a Kubernetes cluster if you want to keep things isolated, or you can run it whatever this code is running within the pipeline. So you can definitely do that. And the orchestration of the sandbox related to code execution will be handled by the Autogen framework itself. And then finally, start the discussion. So we say, hey, user proxy, initiate a chat with the assistant that we have defined up there. Our message is, what is the capital of France? Max turns 3, which means, hey, I'm limiting the conversation to 3 turns. Actually, the comment isn't correct. Silent falls, which means while this code runs, everything will be spit out into the terminal so that we can see that. Okay, so I'm going to run this and let's see what we get. It's going to take a while. I'm running this real time. Yeah, there we go. It's a pretty easy question. What is the capital of France from user proxy to the assistant? And the assistant says to the proxy, Paris. And then it says and then that's where the discussion ends. So we didn't have to go through 3 rounds to stop the discussion. So the LLM did literally follow our instruction and said, right, this is the end of my response. So I know this looks very simple, and that's kind of the purpose of this demo is. But at this point, what we have is a single agent going and doing a task and coming back with its result. Okay. Cool. So how do we go from single to multi-agent then? So in Autogen, you can have several agents with different roles collaborating in a shared conversation to tackle more complex tasks. So the framework supports various communication patterns, 2-agent chats, sequential turn-taking, or group chats to structure these interactions. So the high-level API creates a team of agents and define their roles. A team with an assistant agent, a web browsing agent, a user proxy for tool use, and so on and so forth. Meanwhile, Autogen manages the conversational context between those agents. All agents have access to the conversation history, enabling them to remember prior messages and coordinate effectively. So again, they all have access to the history, and they all remember what they talked beforehand. And that's going to be orchestrated by Autogen itself. And agents can be given tools or skills, a core feature that allows actions like web search or code execution during the conversation. And finally, Autogen provides controls like chat termination conditions that we kind of saw one of them, timeouts, or human in the loop option to manage real-world complexities, ensuring agents don't loop endlessly or go off track. For that, it's going to be our next demo. So there's going to be a bunch of demos, I told you. Okay, for this, let me bring it up. Where are we? Second. Okay. So this is back. Here we go. Close this for a second. Okay, cool. So here's what we have. We have to go through the code again. So we have a scrape page functionality here. You can see that it takes a URL, a parameter set, and then it uses, an API called spider crawling. This is an external service provider that provides APIs capability to go in a scrape web page. So you can implement this with your own implementation as well if you want to. In this case, just to keep things simple, I simply did bring up a third-party service that actually does that through a REST API, and I wrapped that REST API with a function. Then I got crawling. Okay, so which means I'm bringing in 2 different functionality. If I'm not mistaken, I actually didn't use one of those. I wrote it, but then I didn't use it. Well, we'll see. So let's go down. I'm bringing the key, and then I'm defining the scraper agent. So this is going to be a conversable agent. The name will be web scraper, if I can talk. The this agent needs a backing, large language model as well. So I provided a large language model. This isn't going to have any human input. And here's the system message. So for every agent, we always have a system message. And we say like, hey, you are a web scraper, and you can scrape any web page to retrieve its content. Make sure you mark the end of your response with and. Okay, there's still that, finish with an and so that I understand you are done scraping the website and giving me the information that was available on the website. But meanwhile, I'm telling this agent that its job is to do. So the system message is how this agent will know and join the conversation when something comes up that relates to what they can do. That part, the orchestration, will be done by Autogen, and we'll see. So, and here below, I got a user proxy agent. There's no LLM backing this one up. There's no human input either. We're just going to use this through the code that we write. There's no code execution. But there's something else in here. It says, is termination message. Interesting. So this user proxy agent, I want the user proxy agent to look into the content of the message written into the chat. And when it sees an empty content, or when it sees and in the content, this is the content, the message content that is in the chat, right? We're going to have the user proxy and the scraper agent into a chat room. So in the chat room, I want user proxy to check the content of the message that is written. If it's empty, I want to end the discussion. If someone says and with capital letters, which is what I am instructing the scraper agent, I want to end the discussion as well. And then there's an auto reply here that says, please continue if not finished, otherwise return and. Okay, here's the deal. So this agent sometimes has to keep talking. It scrapes some content, and the discussion can keep going. Maybe I'm going to get multiple tasks. We never know. Maybe it's going to need to scrape multiple web pages, right? So I want to make sure this web scraper agent has enough time to talk, but I still want to have multiple guardrails. One guardrail is in itself, like, hey, when you're done, say end. And when you say end, I'm going to finish. When you don't talk, I'm going to finish. But otherwise, I want you to continue talking unless you want to say end. So like I'm coming from different angles here to make sure it will keep talking as much as it needs. Meanwhile, it says, I remind them to say end when it is done. So kind of reinforcing the guardrails here, making sure it has enough space, enough freedom to talk. Okay, so now the next step is to register what? The agents. So register function, scrape agents, caller, scrape agent, executor, user proxy, name, and description. So what is this about? Okay, so this is the registration of the function, of the Python function that I wrote at the beginning of this code. Remember these two? And I told you that I didn't use one of them. It looks like my brain is serving me well. My memory is serving me well. I indeed didn't use which one? Let me see. Scrape page. Crawl page is the function that I didn't use. I didn't even register that. So no one is going to be able to use that. So I'm registering this little into scrape page, which is this one, scrape page function. Let me go down, will be registered. Who is the caller? It's the scraper agent. So the scraper agent can call the scrape page function. Who is the executor? Who is going to execute this? It's going to be the user proxy agent. I'm going to use it as a placeholder or a wrapper. Finally, I give this a name and a description so that we know what this skill is. from the perspective of Autogen. Because so far, until this point, Autogen wasn't aware of the skill of the Python function that I wrote, that is the literal skill of calling the external API to do scraping. So that skill, so far, before this registration, first off, it wasn't registered for Autogen. It wasn't connected to a particular agent. But here, I'm doing the registration. Okay. And finally, I'm going to start calling the operation. I'm going to say, hey, sorry about that. Depending to your time zone, it might be morning, but depending to my time zone, in my time zone right now, it's 11:25 p.m. That's where the yawn came from. Okay, cool. So scraper chat result equals to user proxy agent initiate chat. So I'm starting a chat from the user proxy agent. And let's see what I do. First off, I'm given the scraper agent. I want to chat with that guy. The message I'm passing is, based on this and this website, tell me who Daron is. Give me your findings and write "and" when you are done. Okay, so first off, I'm giving 2 websites. Okay, so far, I gave no special instruction to anyone, not the agent, not the skill, that there might be multiple websites to be scraped, right? So I'm a little bit being, courteous here. And then I'm saying, hey, who is Daron, which is, by the way, me, in case you forgot. So give me your findings and write "and," which is a reminder to my guardrail. Like, once you're done, please say "and." So max turns 3, just trying to keep myself safe again. Maybe this could be increased a little bit. I'm going to use a summary method, but this one isn't going to work because I'm using a modal and the server that isn't supporting this. But if I switch this code to, for example, another modal, this would work. This is the implementation within Autogen. So the implementation in this case is dependent to what model you're using. So you have to look into documentation. I still wanted to keep it in here in case this is useful, but in our demo, it's not going to work. And finally, summary args. If the summarization worked, by the way, what the summarization does is it takes all of the output and resummarizes that through using the LLM. You can even go and give a different LLM config if you wanted to do. I didn't do that. So, but again, the point of this demo is not the summarization. The point of this demo is that we have defined a skill, we did register that, and now we're asking something, we're giving some instructions that would require that skill, and at this point, what I'm expecting is Autogen to figure out what skill, or kind of orchestrate, not necessarily figure out, Autogen to orchestrate the connection between the instruction, the skill, the agent, and make all of this magic work without me doing anything. Okay, so let me save. By the way, if you're curious, I can actually have this question. Go to our first example and say, instead of friends, I could ask about myself. So just to prove that the model I'm using has actually no clue about myself. Let's see. By default, this model doesn't know me. Where's that? Huh? Okay, there you go. I couldn't find any notable or well-known information about the person named Daron. It's possible that he may be a private individual, not a public figure. Ha! That doesn't make me happy. Anyways, okay, so let's try this one. I'm going to run this, and hopefully it's going to go and crawl these websites and get information to be able to answer this question. F5. Okay, it looks like it's executing a function. It decided to execute the function twice with 2 different URLs, 2 different parameters, even though I didn't define anywhere like this could be used twice. this could be used for 2 different parameters and so forth. And I didn't do any of that. And okay, finally, from Extra, based on the web pages you provided, Daron, as well spell as Yendem, appears to be a Turkish coach, speaker, and writer who focuses on wellness, leadership, and personal development. He has a strong online presence, and so on and so forth. So, okay, I love this a little bit better. Okay, so based on the prompt, it was able to figure out what skill to use, and much better, it was able to figure out that that skill has to be used twice before we can get all of the information needed for this particular task. So that was nice. So this gets much more magical when you have tons of skills with tons of agents and you see them working together. Okay. So let's continue. Okay. Advanced Autogen workflows. So what are we talking about? So Autogen allows integration of tools, functions, or external systems that agents can invoke. For example, an agent could be equipped with a Python execution skill, a web browsing tool, or a domain-specific API, which is kind of what we did. So these skills let agents handle tasks beyond text generation. They can do calculations. They can go and query databases. They can be controlling other software or connecting to other software. So the design of the framework supports such tools to be integrated seamlessly within the agent conversation. Agents, again, can recognize when to use a tool via code and get the result and provide back, which is what we have seen. So you might use a powerful but slower model like the GPT-4 or something for a planning agent, and a faster model or a code specialized model for an execution agent. And that's where the power of these multi-agent systems comes in, because every agent can actually be backed up by a different LLM behind the scenes or a different model. And that kind of helps us to even lower the total cost of the execution, because instead of going into the same LLM all the time, each agent can have different models. So Autogen overall supports mixing models to balance the strength and efficiency of these systems. This is useful for domain-specific needs too. For example, a legal domain agent might use an LLM fine-tuned on legal text, while a general assistant can use a broad knowledge model. Autogen provides this flexibility to plug in various models for different, backend agents. And you can provide custom system instructions or personas like we've done to each agent. So you make an agent specifically behave like a friendly customer representative or a strict fact checker. And especially if the fact checker if it is connected to a skill that is connected to a source of truth, like a database or something, that would be really cool. So for complex workflows, agents can be given a long-term memory if needed, or connected to a knowledge base via regular retrieval augmented generation and stuff, so they can retain facts across sessions if needed. So another demo I have here. Okay, let's switch. Oops. Nope. Okay, give me a second. Okay, there we go. Okay, let's go with this. So here's what's happening. Here we have multiple agents. So we have an assistant agent. We have actually a couple of assistant agents. One of them is named manager. Again, we always have to give an LLM to back it up. The system message says you are the project manager. Your role is to break down the project into tasks and delegate them to appropriate agents, the data gatherer, analyst, or writer. So the manager knows what agents are available within the room. Start by assigning the first task to the data gatherer. When the project is complete, include and in your message to end the conversation. So this is a definition of the manager. Then let's scroll. We have an assistant agent that is a data gatherer. I didn't include the skill in here. I could have actually brought in the skill as well. I kind of tried to keep these, demos as simple as possible to the point. So the point of this one is just to bring multiple agents. So that's why I didn't want to, mix and mash the skills and multi-agents and all that together. So for the data gatherer, we're telling the guy like, hey, you are a data gatherer. When the project manager asks you to collect data, provide a summary of the data on the given topic, just do it, right? Okay. Finally, we have an analyst. Not finally, it looks like I went a little bit overboard and we have another one. You are the analyst when the project manager provides you with data, analyze it and provide key insights. And finally, you are the writer when the project manager provides you with analysis, write a concise report based on it. So again, all of these agents could have different, skills, different tools. Right now, just to keep things simple, we are using a single LLM to back up all of these agents, but they all have different personas. So they all going to bring different insights into the discussion. Okay. So one thing that is different here is the speaker selection. We have a Python function that does the speaker selection based on who talked last and then hands over the discussion to the next one. You can customize this. You can, like the way I did here, you can do round robin, or you can leave it to the Autogen. There's an auto assigner as well. In this case, just to make sure the sequence of the things and, fall back to the manager whenever we need. This is the function that I decided to use. And I wanted to have a sample of how to customize, the discussion flow in this code as well. Okay, so we are creating a group chat. So these are the agents we're going to have in the group chat. Max round is 50, so they can talk up to 50 times with each other. This is the speaker selection function that's going to be used. There are no messages in the group chat right now. So this is just the definition of group chat. The chat didn't start yet. Then we have group chat manager. We give the group chat, we give the config. We have a user proxy, as always. And finally, we initiate the chat. We said, please start the project to create a report on current trends in artificial intelligence. And finally, I write the report into the file system so that we can see, because it's going to be a large one. In this case, it's not going to be very large because I'm using a small model. So let me start, because it's going to take a little bit of a time. Once the chat is completed, it went actually pretty smoothly. Okay, cool. So you do see the entire discussion, right? I'm kind of scrolling up. So they're talking to each other, manager to chat manager, task tree completed. It looks like they have split the thing into multiple tasks. Data gatherer did work on this. Manager assigned the task to, and flag task is completed, so on and so forth. And finally, what I have here is this little file. Okay, so I know this isn't very large because, again, the model that I'm using is very small. And by the way, where is that? I am limiting max tokens to 2,000 just for the sake of the demo. So that's why we don't have a very long text. But if I didn't have that limit and I was using a larger model with a much larger context window length, this would definitely be much longer. And you can see different sections written by the different agents. And don't forget that there's a final writer agent that took everything and wrote the report. So this is a cohesive report, where feedback came from multiple agents. Okay, cool. Okay, so what are some real world applications? So multiple agents, you can handle, user inquiries where one agent answers FAQs, another processes account info, another handles escalations, so on and so forth. In education, you can have one agent can tutor, or the other answers the questions, and they're in the same room. They talk with the student at the same room, but in the same chat room, and other there might be other examples as well they can come up with. Challenges and limitations, obviously, there can be a high level of complexity. So designing multi-agent systems can be more complex than a single agent prompt. Agents might miscommunicate with each other or get stuck without careful prompt engineering and termination rules. Those are critical. More agents means higher computational cost. There's also potential latency as agents converse. Optimizing when to use multiple agents versus single agents is kind of important. So LLMs can still produce incorrect information, unpredictable outputs. That's still going to happen. Coordinating them in an autonomous, loop requires very strong guardrails. So from that perspective, nothing changes. So if you want to dig a little bit deeper, here are some resources I wanted to put out there. So there's a beautiful Discord channel when people using Autogen can go in, ask questions, keep up to date. There's another framework that is called Agentic One that is now part of Autogen. I wanted to put the link into that because it has some higher level functionality like multimodal web server, file server, and a coder agent that comes out of the box instead of you taking the primitive agents. Let's say I'm going to call them primitive agents, taking the primitive agents and start building on top of that. Maybe for these, a couple of high-level functionalities, you might prefer having, the additional agents that comes with Agentic One. The code samples that I used in this session, they're all available on the link you can see in this slide. And finally, to keep in touch, here is the LinkedIn QR code. And if you want to grab the slides, here is the URL for the slides as well. With that, that's all I have. And it looks like I am just on time. Love it.
All right. It's time for, I was trying to put your information on the chat and I missed it. Let's see. I have two questions and I'm going to display it. One is, when an agent executes code on our laptop, we practically don't have any control other than trusting agents. Do you suggest another way of sandboxing agents?
Yeah. The ideal way to do that, if you're running it, first off, if you're running it on your laptop, it's on your laptop, you know what you're running, hopefully. But use a Docker environment, and by the way, Autogen supports this. If you have a Docker environment locally on your machine, you can point the code execution engine into that. So it's going to use the containerized sandboxed environment. In production, it's much more ideal to use a Kubernetes environment as the destination to send the code generated by the LLM, deploy it as a container and run them. Again, Autogen supports that destination as a container orchestration environment as well.
Excellent. Our next question is, can you make the agents print out any Python code they relied upon during activities? Also, I suppose you can provide some way of logging all the activities, right?
Yes, logging is available. I didn't get into that. In this case, I simply enabled, to have everything into the terminal so that we can see. What was the previous question, though?
The previous question was
the beginning of the question.
Oh yeah, when an agent executes code on a laptop, we practically don't have any control other than trusting agents.
No, the beginning of the final question. The
can you make the agents print out any Python code they relied upon during the activities?
So, okay, that suggests that the agent relied on a Python code, which suggests that the agent created Python code, which suggests that skill was defined. So unless we go in and say, hey, code execution enabled or true or whatever to Autogen, agents, even if they generate Python code, no one is going to execute it because the Python code will be simply a plain text. So you have to enable that functionality in Autogen so that Autogen exposes that as a skill. And when the LLM decides to generate some Python code, it passes that to the skill to be executed. Otherwise, it's not going to be executed. And you can definitely create logging for that operation. And by the way, the code executors in Autogen, what they're going to do is they're going to get the Python code, put it into a physical file. So that gives you the actual code that runs as part of that entire pipeline as well.
Let me check if that answered Prakashan's question.
I guess we got a yes.
Yes, we got. Hey, you saw it before I did. All right, excellent. I don't have any more questions in the queue, but judging from the chat, people have been very enthusiastic about your talk, and that was very impressive. So I must say, I too, this agentic or agents has been a very hot topic trend line, or a top trend line. So it's really like a great timing that we're, because he actually asked me about agents, and so it was kind of like, oh.
Yeah, I mean, this has been a little bit of a hardcore intro, I suppose, because this is pure code. The idea is that you develop this agentic system, and then you take this and make it part of an application that you're building, right?
Yeah.
So otherwise, there are high-level solutions out there where you can do. I mean, for example, there's this should be in the resources section. It looks like I didn't put it there, but anyways, there's an Autogen Studio where you can go in and visually create agents and assign things and so on and so forth. And that is maybe more suitable if you just want to get some stuff done by agents and you don't want to sit down and write code. So in that case, you can go and use something like Autogen Studio. But here, the idea is that I have this coded so that I can make this part of whatever automation that I can think of, or a product that I'm building.
We have another follow-up question. Do you have any cautions that people need to be aware of in regards to?
Yeah, we kind of covered that here on this slide. Yeah, the challenges and limitations. Nothing changes. Okay. So in terms of challenges or, cautions, things that we should keep in mind, everything is the same, but more, because we have multiple agents now. If there is hallucination, there can be more. If we need guardrails, we need more, because we don't just have one instance of the LLM, we have multiple instances of the LLM, and now they're talking with each other. If we do this properly, the quality bar will be really high, but if we do a mistake, then we have to be very, careful, because the mistake will, the result of that mistake will scale as well. So in terms of, the quality of the things, or, the definition of the issues, let's say, they are the same, but the scale will be a little bit larger. So I guess my point is the guardrails are very important. Keep that in mind.
We are out of time for questions because our next session is coming up in 3 minutes. Daron, thank you so much for your time and your great and really interesting talk. And really appreciate you coming onto the stage here at the AI Summit, and we hope that you can come back.
Thank you for having me.
Yeah.
This was fun.
All right. Thanks, everyone. Thank you, Daron, again. Have a good one.
Thank you. Bye.
All right.